Oh dear. I just actually noticed that I was not recording, so I'm very, very sorry. Okay, I've actually started the recording now, but I'm very, very sorry for not starting the recording earlier. I do apologize for that. Okay, so just reiterate, we're actually discussing about the beginning of C, and we are on task 0 in C Hello World. Now, the question says you should write a script that runs a C file through the preprocessor. The C file should be saved in a variable called C file, and then the output file should be saved in a file called C. Now, for us to actually tackle that particular task, we should actually know the requirements of that particular task. Now, the very first requirement is we will need a C file, which we're actually trying to create right now. Now, the next thing is we will need a shell variable to actually save the RC file. Then we'll then pass this shell variable as an argument, or let's say as a parameter. But argument is the best term to use there. So our C compiler that is now going to read through the file. Now, due to the content of the file, is not going to perform the full compilation process of C. It's just going to stop at the pre-processing stage, and whatever it gets, it's going to save it into the output called C file. That is just it. So the very first thing here is that we are creating our C file. So now we opened this particular file, and then we said that for every C file, you will need this particular header file there, which is actually your standard input and output library. Now we also said that we can just come into the body and write our C program code and then continue with the task. It's going to work actually. But then if we do this moving forward, the Beta linter is going to yell at us. With Beta, if it's your very first time, it can be very frustrating to actually resolve Beta issues. Okay, so we are now actually learning how to properly write a documentation that follows the Beta style. Now, I am actually saying that I am starting here as main now because the name of my function, like the first function here, is main. Now, if I was actually given a prototype as this, let's assume from your 0x02 or 1 that you're actually talking about functions and all that, you will notice that on your function file or your C file, there's actually a documentation for it, and it's not usually main that is there. It's actually the name of the function. So if my function now was actually comp, and I come in here, then I just do something like this. And I do this. Here is no longer going to be main. Instead, here is going to be the function name. Hope that's clear.
Yes, it's
Hello?
clear.
All
Yes.
right, so
Yes.
okay, so that's the reason why mine here is I'm going to change mine to main, because the first function here I'm writing is also main. To some articles online or to some videos you might have watched, you see that you can actually pass in here as a null argument, and then your code is still going to run accurately without issues. But we are being told to pass in this variable called void. I hope we have time. If we have time, we'll go to 0x01 that talks about variables and if-else statements. Then we'll actually discuss about void. But then void itself is a variable. Now there's a reason why this void is actually passed in as argument to this. Now this will actually take you to, if you remember correctly, your arg-c and arg-v. Now that's argument to main. Can we remember? I'm assuming at this point, majority of us here has actually passed C. Hello?
Yeah.
Yeah,
Okay.
function name then arguments.
Yeah. So, and you also meet the concept of arguments to main in your Python, JS, and also in your Bash scripting. So, arguments to main is going to follow you all through the program from sprint 1, sprint 2, sprint 3, except your specialization where you're actually choosing that front end or back end. Okay. So, I think I'll just leave this here as we progress. I get inspired to explain more about this particular argument to me, or when we're talking about variables, I might touch it. I don't know, but let's proceed. Time is not really our friend. All right, so but we actually asked to pass in void here. There's actually a reason for that actually, but let's just keep it cool and simple. So then we actually ask, it is not really asked, but according to the Betty style, we are asked to use tabs instead of spaces. We actually have to use tab as indentation instead of spaces. Okay, so let me quickly complete my documentation part of this particular cipher. So main. Now main is actually going to hold your short description about your file. So for short description, I can just say this is a demo cipher, and it's basically a short description. Number of characters there is usually 80. 80, like starting from this very first one here, not this line here. Because you actually notice here, there's actually a line and column count here. Can you guys not see my screen and see what I'm highlighting?
Yes.
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 Okay. And this particular guy here, you actually need it if you are trying to resolve better issues. Because really, in your C programming journey, better issue is the least problem you can have. Like it's very easy to solve. The problem is we don't know how to interpret the lines and all that. Now, this particular 3, 4 yeah, is actually saying that I'm on line 3:4. That's just it. Or line 3 character, the fourth character, something like that. Yeah, yeah, it's character count actually, not colon. Because you see, this is 4, 5, 6, and it's increasing like that. But for your short description, your 80 line character actually starts counting from the very first one here. So this is just your short description according to the Betty linter style. Now, if you are now going to go more detailed about your documentation, let's say, um, then you using a colon, not an hyphen. Please take note. This is a colon and this is an hyphen. You use your hyphen as a short description for your function name. Now, all other description is just going to take a colon. Now, supposing this main function is actually accepting an argument, according to the Betty style, I will actually have to, let's say the name of the argument is, let me just use void here, since void itself is still an argument to some point. So I could just say void, and I'll still put the colon and type whatever thing I want to give as void. Now, if you are if you are going to go back to your C files or your C projects you've done, you will see that the documentation is actually following this process. So to some of you that just copied and pasted, I don't know what is doing per line. This is what is actually doing. That is why your code is checking. Okay. Now after that, you should add a return statement. You should add the return statement, and then you still put in the colon. That's just it. That's just it for your
Hello.
documentation part. Yes.
Sorry, I'm taking you. Sorry, I'm taking
Talk
you
to me.
back. Sorry, I'm taking you back. I want to know the meaning of void. Like, what does it do?
Okay, that void there is basically saying, okay, void is actually a data type on its own, but it means empty. That's the meaning of void. But what void is actually, if you have your mic turned on, please kindly mute it. Okay. Now, if you put in void in this particular argument, it's basically saying that this my main function is not actually accepting any argument. That's just it. Because oh, great. Okay, sorry. Nice. Okay, cool. Alright. So because this particular file now, this is not doing anything. But if I'm just going to save this and then I kind of do gcc test.c, and then it's actually going to give me an output file. By default, it's actually going to be a.out. Then if I pass in the O option to give it a file name, and let's say the file name is Sammy, the name of the file is going to be Sammy. Now to run it, actually just to do this, right? To run it. Now I can pass in other arguments to it. That's the concept of the arguments to me. Now, if your programs are actually sensitive, now you're actually running on your particular file. If your program is actually sensitive, they're actually going to read this argument that you passed if you don't put void. But then if you put void and you do something like that, it's going to it's just going to ignore it totally, or it's going to pass in error depending on your checks you put in. It's going to put in error that argument is not expecting. Sorry, the program is not expecting any arguments. But sorry, let me quickly admit someone. But then if you come in here and then just do something like this, int a, and then you do something like printf. Yeah. Then use %d. Still remember. Yeah, use %d for integer. Then with this now, whatever argument that I pass, so long is an integer, whatever argument I pass in this and that I'm trying to run, run with this, and this I pass in 7. Now this 7 is actually going to be read and then displayed underneath this particular guy here. So that's just why void is there. So kind of like a check to people that have done Python that has gone to your try and accept. So let's just say it's like if you're try and accept here. Is that okay? Is that okay?
Hello. Yes, it's
Yeah,
okay. Thank you very much.
no problem. This actually need to move. Oh shit. Nice. Okay, to those people that like saw me doing this, yeah, this guy here, I'm the lazy type actually. So instead of me actually breaking down the command to basically do the one, I just compile them into a single one line. So what I'm saying is actually creating a directory called new tutorial, then I'm copying test.c to this directory new tutorial, then I'm opening the test tutorial, sorry, the test.c file. Now if I don't want to actually do that, I can't. The doing in one line. I'm very lazy. Sorry. Alright, so that's just uh that's just it. So that's what the void there is. Are we good with the void now? Hello guys, are we good with the void?
Yes, yes. Let's go.
Okay. And to some of you now that because I kind of combined a multiple commands into a single one liner with using semicolon, please and please go and read about that semicolon I used there because really has its good side and its bad side. One of the bad side is if you're actually kind of running a bash script or a program, or if your chain of files that you're running, like one input here is the how am I going to explain? Okay, the output of one part is a necessity of the input of another. Using a semicolon there is not really advisable. You could kind of pipe it, or you could use other bash variable there. But then, if you want to use the semicolon, yeah, feel free, but read about it first. All right. So now this is our C file. Let's complete our return. I don't need this. Still don't need this. So this is the best way or a standard way of writing our documentation according to Betting. Now, I've also said that if we don't do this part, our C file is actually going to work. But since part of the checker is actually going to check if our C code is Betting compliant. Now, the checker in this particular task is not actually checking your C file, actually, so you are free. But moving on, I think it's worth noting we should know how to write proper documentation with Betting. Wow, sorry, my C skills is a little bit rusty because it's really been a long time. I wrote anything on C. Yeah, I think it's printed. Python is print. Okay, so let's just say I want to just print a string, a raw string. This is let's say Sammy, and then put in the backslash n, then Sammy this. Okay, okay, so now we are done with our C script. Sorry, we are done our C file now. Now if I actually do Betsy, and check it. Okay. Now I have issues here. The same on line 4, I have trading white space. Also on line 11, parentheses are required on a return statement. Okay. That's it telling me that has been a long time I wrote on C. Okay. Total errors is no description found for the return value of main. Okay, so let's tackle them one by one. The very first one here is on line 4, trailing white space. Okay. What you could actually do is do this and then do this. Okay, well, Mr. So line 4, I have a trailing white space. Sorry. So line 2 now. 1, 2, 3.
Still, I think it's still there. It's
Trailing
still
white
there.
space.
So
1,
is
2.
that your return? That your return is not wrong
Yeah.
with your main. Return. No, from the comment.
Okay,
Return from the
okay.
comment. That one in
From
parentheses.
here.
You need to close that bracket. Yes. That R. So just do exactly. So
Sorry.
this return needs parentheses, brackets.
So let's see. So I still have line 3, trailing white space. There's a way I can actually use cut command.
Yep, we're cool.
No, no. Why it's taking so long here to load? Alright. So
Mhm.
it's somewhere here. Yeah. So there. And then everything should be fine. Okay, so we are done with the C file. Now the next part is the shell variable, right? Are we following, please? Hello, are you following?
Yes, we are following.
Yes, we are. I am
Yes, sir,
following.
we are.
Uh, okay.
Yes, we are.
So the next part is actually creating the shell variable. Now it says write a C file is actually going to compile a this C file. Oh, sorry, write. Let me just open this question again. The write a script that runs a C file through the preprocessor and saves the result into another file. So you have a C file. Now it said the C file name should be saved in the variable C file. Now that $C file there is actually telling you that there's actually going to be an expansion coming from your shell expansion. I think the beginning of your system engineering DevOps. There's a particular project that talks about shell variables and shell expansion, right? So this particular dollar symbol here is actually going to be expanded. So probably I want to let's say I want to do this. Now, this guy is actually going to expand to mean the user's home directory, just as the same thing if you do cd. Because if I still do this and do,
Hello.
yeah,
Um, I have a question.
yeah. What's the question?
Like, how do you move back from, you see those two greater than sign. How do we move out of those signs to the root to your root?
Like, how do I move from here? Yeah,
The greater
like from
than after
this. Okay,
PW.
these guys here.
Yes.
Just press Control D or Control C. You're just going to send a signal to um your process to kill it. You still do that in processes and signals in system engineering DevOps. That is if you are coming from current 11. But for 9 and 10, I don't know about 10, but I think 8 and 9 should have done processes and signals.
Okay. Thank you.
Okay, so I mistakenly exited from my virtual machine, so let's just wait, let it come on. Okay, so what if it comes on now? Since we actually have our C file, the next thing we're actually going to do is to just create a shell variable that is just going to hold the name of our C file. That's just it. Now to do that, you just have to use the export keyword. Uh, any question?
Hello, good evening.
All right, good evening.
Sorry, I'm joining the class late. I tried to join. I was on transit, so I joined and I left. I just came into the house to join the class. Sammy, good evening.
All right. Okay,
Thank.
if you're just joining, don't worry, this session is actually recorded, so
Okay.
all is good. But
Yeah.
we are just giving ourselves a refresher, which is it's a refresher for me with C, because really I think it's 9 months now. I wrote on C, so and actually ask for forgiveness if my C skills is rusty. But then I think there are some basic things I still remember. So we're actually
Okay.
doing a refresher on C,
Okay.
and then we are on Hello World.
Okay.
We are on C Hello World, and then we actually are talking about this fixed tax here, which is running the C file through the preprocessor. So we've successfully created our C file.
Okay.
We successfully created our C file, which is this test.c, and actually explains why we needed this C file. Now, after creating this C file, we'll need to create a shell variable to hold this C file, because part of the requirement there says that the C file name, the C file should be saved in the variable called C file. So if I'm actually going to create a shell variable and make it global, I'll need to use the export keyword. Now, if I
Okay.
don't do this, um, for those who will be doing your Airbnb clone, yeah, I think that should be code 9 now. To some point, you need to create like a local variable. Yes, you need to create a local variable. Now, if I want to create a local variable that my immediate function or process is just going to use, I can just do the name of my variable. Let's say the name is Ken, and then the value. let's say let it hold test.c. Now if I press in enter, I've successfully created a local variable. But
Okay.
to make it a global variable, I have to add this export keyword there. So that's just it.
Okay.
So that's the difference. Now,
Okay.
they said our variable name should be cipher. So this is it.
Okay.
Now I'm going to click on enter. Now if I'm going to do if I'm going to do env. Now if you look closely, you see here, right here, I have the variable cipher, and its value is test.c. Can we see that?
I can see C file test. Is that what you are? Is that what you
Yes.
have there? C file test.c.
Yes.
Okay.
So
Now, please,
like
please,
so,
let me
yes,
ask, please. The ENV stands for environment.
environment. Yes.
Oh,
You could
okay,
still use
okay,
print env like this.
okay,
And as you can see, it's just giving me the same output. So is that cool?
okay,
All right. So since I've successfully created my shell variable to test it out, if it's actually working, I could do echo. Now to use a variable, you have to put it in an uppercase. Then you precede it with a dollar symbol. Now this dollar symbol is telling the shell that you want to use the value of this variable. So what is actually going to happen is that your shell interpreter is going to come into the list of its global variable and look for a variable name called cfile.
okay,
Hmm? Then
okay,
grab that value, which is this. Come back to your command, replace it with that particular value, then perform the action. That is just it.
okay.
Simple and easy. Now let's
Um,
see.
um, can
Hello?
I still say something?
Yes,
Okay, please. I noticed you are using the Vagrant Ubuntu stuff, right?
yes, I am.
Okay. To those of us that we are using Bash, the Bash now, the Git Bash terminal, because are they different? Are the terminals signs and terminal code different? Because me, I'm so familiar because on my system now I use the Git Bash, but on my phone, my Android phone, I use the Tamils this thing apps as the terminal now. So are they different from the Vagrant? Because I could not install Vagrant on my system. I actually tried installing, I could not use it. That's just the challenge. So now, as what you're doing here, because I see you using echo dollar sign C file. The echo here is on the other terminal now, the Tamis terminal, when I'm using the Git bash, I use it as creating a README file. Is it also same? Are they working the same?
Okay. Okay, so, well, okay, let me explain this.
Okay.
Currently, right here, I am actually on my Vagrant virtual machine.
Mm.
Oh, however, the CLI I'm using is Git Bash.
Okay.
Are we getting the gist? Now,
I'm
on
with,
your Linux, which is on Android, I think you
yeah.
also have other Linux Android environments. Now,
Yeah.
on your Thermos is actually installing a Linux environment on your hardware, like on your I think it's on your roots because if you're actually going to do, let's say, if you're actually going to do something like this on Temox, and then you continue following, you realize that your default home directory is something, can I remember the past? But it's actually, you see something like user
Yeah.
temox.com forward slash, yeah,
Yeah.
user,
Yeah.
yeah, we get, so that's your default directory. You get,
Yeah. Yeah.
because it is actually installing your that Linux environment on top of your Android OS.
Yeah.
You get the gist.
Yeah.
Now, Git Bash itself, yeah, it's just a CLI that allows you to run commands on your Bash script, command on your Bash environment on a Windows environment.
Okay.
Like if you actually spin up your Git Bash environment now, and let's assume it's a Windows machine now, not a Mac machine. If you do ls on that your Git Bash, it's going to list all files in that your current
Yes.
directory. Now,
Yes.
if you take that ls to your CMD prompt, it won't work. The
Okay.
same thing on your Bash, on your Git Bash now. When you open that CLI there, you can type in a bunch of commands and you press in clear, just like I will do here now, like this.
Hmm.
It's clear
Yeah.
my screen.
Yeah.
But if you go to your CMD and you type in clear, they tell you error that it doesn't understand.
Okay.
So the Git Bash is not like it's a separate environment. The Git Bash is just like a CLI that allows you to use your bash command on your machine,
Okay.
irrespective. You get.
Okay.
Now, Termux itself, you can still call it like a CLI, but then you still have to, but more or less it's like a Linux environment there because you can install packages, but on Bash here you can't install packages.
Okay.
So that's just it here.
Okay. 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 I
Okay,
get. Thank you.
no problem. Wow, that time is fast spent. But I think we actually gained a thing or two. Okay, so right here, the name of my sorry, I actually saved this. This is the name I actually saved this. This my test here. This is the name I actually saved it with C file. So for me to use this variable, sorry, I was actually using um this here. It didn't work because it's the same. You see, it's just basically um printing out a new line character. Now the reason why it's actually printing out a new character actually goes back to how the echo command is actually working. By default, is going to add in the new character. So because it couldn't get this variable inside our global variables, it just printed the new line. But then I remember that okay, it's the exact name that you used in creating the variable that you actually use in using the variable. So I actually changed it from an uppercase to the exact lowercase that I use here. Are we good? Hello, are we good?
Yes, yes.
Again, I apologize for some of these mistakes. It's been long
Yeah.
while I used to.
Yeah. Well, with
Okay,
you.
so so this is it. So when I did echo this, you see I get test.c, and I can also do this echo test.c, and you still see it's test.c. So what is actually happening here is that when this my shell sees this dollar sign, it's basically telling me that okay, I want to use the value that this guy is should I say pointing to? Yes, we can say it's pointing to it because as we go, we might get to pointers in C. And for our Python class, we'll still need it. When we're talking about, well, let's leave Python for Sunday first. Okay, so that's what it's actually saying here, that this value or that whatever this guy is pointing to, I want to use it. So what our interpreter is going to do is going to look for where it saved this C file in its memory, grab the value, and replace it here, just like this. And you can see echo $C file printed test.c. The same echo when I replace echo $C file with test.c, you can see it actually gave me the same output. So that's what is actually happening. And for your bash scripting for Cohort 9, you will need that also. So yeah. So did you get that part?
Yes, yes.
All right. So for preprocessor now, yeah, and to the guy that said that he's actually using air code to create README, I
Yes, I
would say
was
it's
the
not really,
one.
I would say it's not really advisable. But if you are actually typing in short content, you can use echo and your redirection as echo. Then no, let's say you use the double quotes, and then you do something like this. But if you are going to be writing complex things, just use Amigito. So you
Yeah,
use echo
please,
basically, yes?
please. I just see you put in a new code. That's interesting. I used to say, like I said, I use the batch this thing to do my work. Now, each time I want to make a README, like I try to talk the other time, I just say echo single quotes, README file, README space file, close the quotes. Then I put a directory sign, and then
Yes.
I space and put a capital letter README. Now, from what you
Okay.
just showed now, can I just say echo double quotes, then directory sign, and then put a README?
Okay. You see, this year and this year, they mean two different things.
Yeah.
That's what you should know.
Okay.
That is the reason why, if you are doing your Git commit,
Mm.
sorry, it's more or less like a revision for both parties, for you and I.
Okay.
If I'm doing Git commit, I didn't spell it this way. If I'm doing Git commit,
Yeah.
I could do single quotes here, and it will work. And I can
Yes,
do say
that's
double quotes.
yeah.
Okay. The difference is that this guy here, this one here, is suppressive. This isn't. By suppressive, I mean if you are actually going to be using variables or special characters, if you are putting it inside a single quote, this single quote is actually just going to nullify it, or in this case, suppress it to just mean their actual value.
Okay.
Like we know that \n is actually a new character, a new
A
line
new
character,
character,
right?
a new line. Yes, a
Yes.
new line
But if
character.
I put this inside this, instead of it passing a new line character, it's just going to print \n.
Okay.
But if you put this in this, it's actually going to read it for its meaning. So this one actually allows you using special characters and special variables, while the other doesn't. However,
Okay.
if you really want to use it, there's you could actually do something like this: echo, then you put in the E option. I think. Oh, come on. Let's just check. Yeah, you could actually use the E option. You could see it here,
Okay.
and then
Okay.
all is well. But I would advise you to actually use an editor, because have you checked my GitHub? If you check my GitHub, you see that if I'm actually going to be doing those echo readme and this all of that, I won't be able to write it conveniently. All those my readmes conveniently. So you just have to use
Okay.
an editor. You get.
Okay.
All right.
Right.
Okay. So we've settled. It's almost 9:30. So we've settled the part of the creating a cipher, creating a variable, which is cipher. Now, the next part is allowing this uh, file to run through the preprocessor. Now, back then, I really I didn't have much time. So what I just did was to do my GCC, and towards the end, towards the end of this particular, yeah, somewhere around, yeah, towards the end, you are just going to see the necessary GCC flags for that, or you could just do a Google search. I think it's somewhere here. Come on. It's somewhere here in this manual for GCC. The option is actually S. So if I'm doing, let's see. Okay. So if I do GCC passing the S option, and then since we've established this, then we should have another file called C. So what I just did here was you use this S option to pass it through the preprocessor, because we know the C compilation process. So now, since I've explained what this guy is doing here, now GCC file is actually going to need a C or a C++ file, because the term GCC is actually the GNU compiler for C and C++. That's the GCC there. While CLang is only a compiler for C. Alright, so that's just side notes there. So what I did, GCC, the S option that tells it I'm running into the preprocessor, the name of the file, yeah, this guy is going to expand to this guy. Now the O option is me saying I want an output file for this, and the name of my output is C. That was why before I ran this command, when I did an ls, see I only had one file called C, test.c. However, after doing this, yeah, and rerunning the ls, you see I have the file called C. Are we good? Are we good?
Yeah. 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 I'm here.
Alright, so we're done with the tag 0. Now, the same thing you did in tag 0, you just have to repeat it for tags 1, 2, 3 also. Yes, for tags 1, 2, 3. Now for tags 4, it's actually saying you should write a C program that prints exactly programming is like a building a multilingual puzzle. Now it said if you use the function put s. Okay, so if you have a function and you don't really know much about it. This is what I do when it's C, not other languages now. This is what I just do. Man the name of the function, which is put this. And just like that, I will just get a like a foreknowledge about that particular function. Are we good?
Yes.
Yeah,
Hello.
yeah, yeah.
Okay.
I'm
So
following up.
okay. So this is what I did then. I just used the man page for it. But I wasn't familiar with majority of these terms. So I combined the man page, the little I could understand from the man page, with Google search. So I just did so I just did google.com documentation purpose S, open it on one tab. Then on another tab, I just type put S function in sync. So I read those tabs, the numerous articles that it came out with. I read those and it gave me an idea of what to do. Bringing that knowledge, then combining it with this little manual here, I was actually able to do that, do the hello process. So let's just explain. Now this process, it's saying that it's actually defined in this library. So first things first, before you can use the process function, you will need to include the stdio.h. That's the first thing. Now, the process has its families of functions. You have your f put s, so f put c, f put s, then put c, put char, put s. Okay. Now, your f put c and f put s, you will need that when you're actually doing file IO, when you're reading and writing to files, where you're actually using a file descriptor. But then we'll leave that for them. Then your put C is actually going to read a single character. That is the C there. The meaning of all this guys here inside this parenthesis, this guy here is actually where it's reading from, and this guy is a variable is actually a variable is actually going to hold the contents that it has read. So you can actually read from your standard input or from a file. That is why this guy here is called a string. So it's still the same thing. Yeah, yeah, yeah. Okay. However, for your put char, well, I think moving on, you will start using put char. Yeah, I think, yes, I think from interest, I don't remember again. But then you use put char rather. Now this is what we are actually concerned with. So what is actually saying, let's just go down. And it says that it writes the string S and a trailing new line to the standard output. That means just like the way echo is actually going to print out a new line, this guy is actually going to read the variable or a string, and at the end of it, this is a new line to read. So let's go and use it. Now for us to use it, we actually need a string. It therefore means that you should know the difference between a character and a string. By the grace of God, because time is fast spent, next week Friday on another session or see, we'll talk about variables and then we'll kind of explain all this. All right. So let's just come here. Yeah. Now, my process is actually going to take a string. I can pass in the string directly, just the way I did it here. Or I can pass a variable into this, whichever way. But if I'm actually going to create a variable, let's say my variable is str. So this is the right syntax for it. Yeah. So I can just say this is my string. Just say this is my string. This is one way I could declare a string in C. I can also do something like this. This is another way I can declare it. However, this is the most popular way you see in string. Now, this particular concept is very, very tricky because this, to some point, is referring to pointer. That's fair. So another point is actually referring to a string. So let's just keep it simple. So I just have to pass it directly. And then the string that they said we should print, just going to copy this and paste it. Now the problem here is that the part of the things I want to print is this double quotes. Now for me to do that, I will actually need to put in a backslash. Now what is this backslash doing? This backslash is like an escape character. Because without this backslash, what is actually happening here is that my put s is actually seeing the first opening of double quotes as the beginning of my string, and this next double quote as the ending. Now it is not acknowledging anything from this part here down to this part. That's why if you look here, you see that it's just showing this particular color. However, if I come in here and you put this, see that everything falls in line and everything is in its place. Is that cool? Is that cool? Hello? Can you hear
Yeah,
me?
definitely.
Yeah.
Yes, yeah.
Okay. So I'm just going to save. And then if I'm going to run this, now you can see I have this one here, Sammy. This first printf is actually coming from output s. So just like so, we've been able to do tax 4 on the 0x00 hello world. Now tax 5 is saying you should actually use the printf function, which I actually did using this Sammy that I actually printed this time. Now
Hello. Sorry.
for Yeah.
The number 4 question said your program should end with the value 0.
Yep.
What
Okay.
does that mean?
Now for every successful program or for every successful command you run, there's actually an exit status. Okay, so let me briefly explain that. Now, when I did VI is a command, and test.c is an argument to the VI. Are we cool with that first?
Yes.
Okay. Now, when I did this, I've actually opened this session, a running process, which is part of the things you need to understand when you're actually writing your simple shell project. Let's assume you are doing your simple shell project yourself. You will actually need to know this stuff. All right. Now, I'm on this session here, which is the VI editor. Immediately I close it. Now, the exit code or the exit status of the VI command is going to be returned to the shell. Now, for me to see that exit status, I just have to use this shell special variable, which is this dollar and this. And this is actually going to give you 0 for every successful program, for every successful command you run. If I do this with man GCC, or let's just say man puts, and then I close this, and then I return this, so long that command was successful, it's always going to return 0. It's not that whatever we did here was actually correct. Nah, it's far from it. Hope you get that part well.
Yes. Then, sorry, the last one.
Okay.
So can you please explain the semicolon, and then I think did you run a file called a dot out?
Yeah. Yep.
The semicolon was for what?
Okay. Earlier, I actually said I am the lazy type. Like I hate running. Let's say I want to create a file, and then, or let's say I want to create a directory. After creating the directory, I want to create a file in that directory. And after creating a file in that directory, I then want to open a VI session and add in something. Now, the very first step is to do mkdir, the name of the directory, right?
Yeah.
And then press enter. After that has run, I'll then do cd into that directory, or I can then do something like vi, the name of the directory, / the name of the file. I mean, if I want to skip the part of first of all creating the file. But if I want to create the file, I can say touch the name of the directory / the name of the file, then vi, the name of the directory, the name of the file. But I'm very lazy. So what I did is to merge it into a single line. Now that semicolon there is telling the shell that the command before the semicolon is separate from the command after it. So it's still the same thing as me doing this in multiple lines, but I just did it in a line. So what is actually going to happen is that it's first going to run this command, get its exit status, then run this next command. Now, the reason why I'm able to pass in a dot out, which is why I said you should be very smart when you're actually going to use the semicolon. The other one-liners, you should read about them. The disadvantage of this is that this command here is going to run irrespective of this command. as such, you should be very careful when you're using it. I'm able to use it because I know that I didn't pass in any further arguments to this GCC. And if I do this by default, the output is going to be a dot out. So I just did GCC, put in the semicolon to signify that that's the end of that particular command. Now it's going to run, get its exit status, then go to the next one. Now because this runs successfully, of which I know it's going to run successfully because I knew I wrote it correctly. So you should know, you should see from this explanation, you should even know when you should use the semicolon and when you should use other one-liners. Probably you can even decide to use, well, there are other one-liners you could use. So I then ran a dot out. So that's just it.
All right, thank you.
Okay,
So
so
I
any
have
other question?
yes, sir. I have a
Talk to me.
question, sir.
Talk to
Please
me.
open the VI to the file. I want to show you something. I want to know the difference between puts and printf because the output of your code, both of them generated the strings. Like this puts, it printed out the output, and printf also printed out. So can we use these puts in place of printf when we want to print out on the standard output?
No. Okay. Let's just even explain the difference and or let me put it this way. Let me give us like a foundation of printf and puts. Then I'll leave us to go and read about them. Then we'll understand the gist. Now, printf, that f there is actually a format specifier. That is why in your printf, you can actually come here and let's say %g. And in here, I could say 10. I could say, let's say 10 or 1. Well, let's just say 1. I could say 1 to %d. Now, this %d is actually a format specifier. That is the beauty of using printf functions, because when we start doing variables, you realize that you could actually, though you have a variable that is holding a character, let's say character A, with printf, you can actually format it to print out its ASCII value that is actually in digits instead of the exact alphabet. But with puts or with puts C, is literally just going to print out either a character or a string. Now, printf is giving us the flexibility of adding more functionality or formatting our output. You can see now I'm formatting it, but in puts, I can't do something like that, like something like this now, and do %d, and then come in here and say then there's problem because it's not designed that way. And if we actually look at the prototype, it's actually taking a single character, not two, sorry, it's actually taking a single argument, not two arguments. These guys here are actually taking two arguments. But this guy, which is output S, is taking a single argument, which is S. And S in this context is a string. So if I'm coming here to do this, it's just going to read it as a normal string, but it's not. It can't format it. Like I can't format it, or I can't manipulate it to my desired output. That's where printf comes in. With printf, both of them can actually print a string, but printf can actually still print a digit. Puts doesn't. There's something I didn't make mention. If you look at this, it's actually going to return an integer. So with this return value, sorry, I'm actually going too fast. But with this return value, I can, let's say I'm feeling lazy again. I can do something like this. And then, although this is very stupid to do, but then let's just do it. Then as argument to it, I can put in this puts function call to it. It's still going to work. You can try it. It's still going to work. Or let's say you want to get the return value. I could still come here, and then though this is against Betsy, since it's actually going to return an integer, let's call my integer digits. I can actually do this and then come here, change this to the right digits. And you know what, let's just save and run. Now you can see, this is the return value, 52. Now what is the return value saying? It's saying the number of characters that it's read. If you count this thing, starting from here, this opening one, count it, is up to 50. So, are we clear with that? Are we clear?
Yes. Yes, sir. Thank you.
All right. Okay, so we are moving. We just have 8 more minutes. So for task 6 and 7, for task 6, this is basically where you actually need to move out of the box. Yeah, you can write a C program that prints the size of various types on the computer it is compiled on. Okay, now they're actually telling us that we will need to install some packages, which is the libc 36 and the says we should install the libc dev 36 package that can actually help us to run to kind of imitate an environment of a 32-bit machine. However, because for this particular task, the checker is actually going to run your answer file on 2 different environments. On one environment is actually going to be a 64-bit machine. On another environment, it's actually going to be a 32-bit machine. That's one. Or they can actually imitate a 32-bit machine environment. That's if you look at the first argument to GCC command on the task 6 there, you see that it is GCC 6-size.c. Then you could see and as an argument they are passing M32, meaning they are like creating an environment of a 32-bit machine. And the same thing to the next one, which is actually a 64-bit machine. Okay. So now to actually do that, let's assume you don't install the package. Because really, I didn't actually install the package. This package, I didn't
Please
actually.
just go back to what you were saying about 64 and 32 gig. Don't be angry.
Okay, for every machine, there are two types of processors. This is a 32-bit processor or a 64-bit processor. However, the majority machines that we have now, like majority laptops that we have now, are majorly 64-bit machines. But older versions are actually 32-bit. Are we good?
Yes.
All right, cool. So now, depending on your machine, there's actually going to be running your C program. Depending on the machine, it has a way of defining of the size of the data types. Like for a 32-bit machine, the size of an integer is 2 bytes. But for a 64-bit machine, the size of that same integer is 4. For a 32-bit machine, the size is 2. But for a 64-bit, the size is 4. Now, so let's say now I'm using a 32-bit machine and I write a particular file or program and it works correctly on my end. Now, using the same 32-bit, if I send that program to you and somewhere along the line there is a place in the program that I am actually using that particular size to do other tasks or do other execute other instructions, the program will crash me giving it to you that is running it on a 64-bit. Are we good to that point first?
Yeah.
Okay. Now to make this thing very friendly, and as such you get to appreciate this when you're actually doing dynamic memory allocation. That's for uh quad 8 9. I think 10 should have done dynamic library. I don't know. Those your malloc, calloc, and free dynamic memory allocation. If you could remember correctly, you must actually request for the amount, the size in bytes. Now you could actually basically pass in malloc. You could do something like this, like malloc 50, and to work. But for dynamism, it's actually advised you actually use the size of operator. Now the size of operator is just going to get the particular size in bytes due to the current machine. So if I'm on a 32-bit machine now and I do size of int times str of a particular variable to actually ask for a space from the heap. Now that particular program is going to work well for me, for a 32-bit machine. If I give it to you without using that size of now, chances of it to crash. Because when it gets to that part to execute it, and there's not enough space, you see, there's problem. Because in most times, it is not actually moving from a lower version to a higher version. It's actually moving from a higher version to a lower version, although we are being trained to make any upgrade kind of a backward compatible. But not everybody they put on. Sorry, I'm using pitching. So that's just it. Are we good? Are we good?
Yeah, that's good.
So to actually do this particular task here, so I will just do here. Don't think I need this part again. So instead, Let me do. So this is just the answer. Then you, in place of int, yeah, you replace it with char, float, long, and like so. So this is just the answer for the task 6 there. Because here now, if they're actually going to run this particular file in a 32-bit machine, this size of operator, yeah, is just going to get the size of int based on a 32-bit machine and display it. If I'm running this on a 64-bit machine, this size of is just going to get the size of int based on a 64-bit machine and put it here. And so I don't need it to kind of install any package. So we good up to that point. Okay.
Yes.
So let's just run. Alright, so okay, change that. So you can see size of int is 4. I change the int to, let's change it to long. Now you can see it's 8. So that's the answer for task 6.
So, assuming you were using a 32-bit computer, you would
Now
run
if I was
this.
using a 32-bit machine, instead of 8 it will be 4. Instead of this 4 now it's going to be 2.
But if you want it to be 4, that's when you start using this M64 output.
Yup. So are we good? Alright, so it's already 10 and I'm very exhausted. Okay, so listen, I think you just have one more task there. Yeah, I think it's just 7. Alright, write the script that generates the assembly code. This particular one, I just did a Google search. That was how I actually got it. And then, if my memory is serving me well, I think this still going to pass it with the preprocessor. However, I'll need to pass in a third argument. Yeah, I think this is it. Yes, this is it. Then this, which is this one. This is, and then probably want to save it as an output. So, huh?
What's that new argument?
It's actually an argument. This MASM, right?
Yeah, like what does it do?
I have no idea. I just did a Google search and I saw it. So I just used it.
But
So
can you explain the question?
Huh?
Write a script that generates the assembly code.
I can't hear you clearly.
Okay, like I'm reading out the question, but I wanted to understand the question.
Okay. By understanding the question,
Yes.
the thing is, when I did when I was going through that GCC stuff, I couldn't see a particular option that would enable me generate it in Intel format. So I actually had to just go down to Google, and that was how uh, as kind as Google, they gave me this MASN as an argument to the GCC command. However, now to understand this particular file or this particular question, it's still following the same process. The first thing, you actually need a C file. The next C file needs to be saved in a variable, a shell variable, which is actually a global variable called C file. Now, this C file is actually going to be run with your GCC compiler. However, it's going to generate the assembly code in Intel syntax, not because you know that in your C compilation process you have your preprocessor, your your assembler, your compiler, and then your linker, right? Now, if you are going to pass it through the compiler, it has its own option. I think it's C. Sorry, I think it's C. Then to get the object file is O. Yeah, I can still remember correctly. To get the object files like so. But the problem is getting it in Intel format. That's the issue, because just getting the assembly code normally, you could do it with from doing my GCC, reading the manual there. You will, at some point there within the manual, I think towards the end, yes, towards the end, you will see where they actually tell you each argument and what it's doing. But the problem is finding the exact one that is actually going to give you the assembly code in Intel syntax. So that was where Google came through for me. So if to many of you that actually just copied and pasted it, I'm telling you the genesis of where the MASN came from. Is that cool?
Yeah, thank you.
All right, no problem. All right, I think we will have another one. Okay, for this particular one, I'm very exhausted. For this particular one, it's saying write a C program that prints exactly, and that piece of art is actually a string, followed by a new line to your standard error. Okay, to standard error. Okay. You said you're not allowed to use printf or put f. So again, Google came through for me. Yeah. Because as of that point in time, I never knew printing to standard error. I was only familiar with printing to standard output. Like this now. Let's see. So I can actually say there's a option again. And it's this.
Can you clear your screen so I
Okay, sorry. Oh shit. I've forgotten how to redirect to standard error again. However, back then I never knew how to redirect to the standard error. I'm only used to using the standard output, which is this particular your screen here. You get, so I actually had to use a Google search for it.
sorry.
Yeah.
I think like what's the printing to standard output? Don't be offended.
Huh?
Like
I
printing to
can't hear
standard
you.
output. Printing to standard output. You said it's just on the screen. Okay, like echo.
Okay, so you basically have a buffer. Yes, let's just put it that way. You basically have a buffer. Now your buffer can be a file or your screen. That's why in most cases it's actually called a stream, a file stream. You get. Now, if you're doing your file IO, instead of you writing to the screen, to the standard to like to your screen here, you can actually write to a file. I don't know if we've done,
Yes.
if you remember from the file IO tags in C. Now, your standard output is like a display. It's just that by default, it is just going to mean your screen, your current console. And that is the reason why you could actually, like what I did here now, from what I did here, I actually redirected whatever is going to ought to be displayed to the standard output to a file. But nothing actually displayed. You get, so the standard output is like a file stream that um you could actually manipulate. You could actually make it to write to a file. You can actually make it to write to another file, to multiple files, or you should actually make it to write to your screen. Although by default it's going to write to your screen. Are we cool?
Yes.
Are we cool with that?
Yes. 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 Yes.
So that's just it.
Yes.
So for your standard output, it is one. That is like the file descriptor for it. Now, file, you're not hearing me say file descriptor. You just have to, you will read it about it. You read about it. Go and I think you should, that should be under your file IO. Yes, insane.
Mm.
You read about file descriptors. That's the reason why if you're actually choosing a file descriptor, 0, 1, and 2 is actually predefined. You can't use it because they are already used. 0 is standing for your standard input, right? Yeah, 0 is standing for your standard input. 1 is standing for your standard output. 2 is standing for standard error. Yes. So that is just so whatever number is available for you to use as your file descriptors, except 0, 1, and 2, because they already have their default meaning. So by default, when you're actually doing all this stuff, it is actually basically in on the file stream. Like if you remember from, yeah, on this file stream here, I can actually make it to write to a file just using this putc. But on this file stream, it's the default here is actually your standard output, which is 1. So that's what is actually happening there. Why even on your printf too, it's like defaulting to the standard output, and the standard output is 1. So because I'm not actually like redirecting it to a file or on another stream in this context, it's just falling back to my screen here.